Hello, good afternoon everyone. Welcome to Liquid Brain. Sometimes it is necessary to combine different heat map together in the same figure, either because they're from a different study, they're from a different data set, they're from a different database, and different treatment, different group, and so on. So this video is an attempt to help you to how to combine your heat map into the same figure and export them nicely in the same graph. So if you don't already know, this is actually a part 3 of a video series using a package in R called ComplexHeatMap. You can actually download the original documentation in the video description down below. I'll put a link there, and you can actually have the exact script that you're looking right now also in the video description below. Just go to my GitHub page and go to ComplexHeatMap Part 3 Combining Heatmaps.rmd file, and you can open it in your RStudio or any kind of IDE of your choice, and you'll be looking at this right now. So let's get started. So before we start, I always have like kind of a cosmetic chunk in the beginning, so you can kind of ignore that. But if you do want the documentation, I also put a link to the documentation, which I find very useful, and you can also find a book that the author have written. The author of this package have written in the video description down below. So for those that have not actually installed the package, the second chunk is supposed to help you to do that. You can actually just install the package from Bioconductor, which is actually just like a package depository, and you can get the package called ComplexHeatMap very easily. But don't install it every single time you run the script or open R. You just have to install it the first time, and subsequently you just have to run line 19 to actually load it into your environment. So after we have loaded the package into our environment, it is time to create 3 different data sets to create different heat map before we can combine them. So the first chunk over here just attempt to create a matrix of 10 rows and 10 columns using the rnorm function. And the second one, the matrix 2, is attempt to do the same thing but using a runIf function. So slightly different way of generating random data, but the fundamental concept is the same. Matrix 1 and 2 both contain 12 rows and 10 columns. So the third matrix will be a little bit different, where it's supposed to just contain 12 elements. So just supposed to be 12 elements of A, B, and C. So you can actually have a look of LE. So LE is supposed to just contain A, B, and C and its individual character here. So once we have created that 3 matrix, it should show up on your global environment here on the top right. You can actually click in and inspect them. That will be the easiest way to understand what you have just created over there. As you can see, 12 row, 10 columns. So once we have done that, you can just pipe it into a heatmap function using the ComplexHeatMap integrated heatmap function. So just remember that heatmap itself spelled with a capital H. The lowercase heatmap h, lowercase h, is from a different package and different function. So this will be the default heatmap that you got from heatmap. So you can do that with, of course, the second matrices. So you can see that rnorm and runIf already generated slightly different looking random data. So for the third heat map, because it's just lattice, so it will automatically assign different colors to A, B, and C and plot them out. But you can see that it's just a flat line because we only have a single column. So now comes the question, how do I combine the 3 of them horizontally? I think that would be the first thing that I want to do. Okay, so combining horizontally when you have everything with the same number of rows. So matrix 1, 2, and 3, in this case heatmap 1, 2, and 3 both contain 12 rows. So since they're all the same, you can just run ht1 plus ht2 plus ht3 to combine them horizontally next to each other. So the order that you do it is going to be it's going to determine the location of how they show up as well. So it's going to be 1, 2, and 3, and so on and so forth. And each of the heat map is going to have their legend on the right side as well. And they will be named based on the name that you pipe into a heat map originally, which is why you can see when we plot the heat map, there's supposed to be a name for each of the heat map, so that when we look at the legend, we can kind of tell which one is which. But of course, not that clear which one is rnorm and runIf, right? So there are better ways to do that, which we're going to show you down below. Okay, So before we do that, let's try to combine them in different ways first, and we'll go into your column titles and all that. And if you are very impatient, I suppose that I'll add some timestamp. I think that's in your comment. They can just jump straight to the place that you want to go. Okay, so to combine them vertically, we're using, instead of plus, which combine them horizontally, we're using a different symbol called %v%. So in this case, is vertically combined HT1 and HT2, so we can see that they are vertically combined, but the third heat map is unable to be added because they're slightly different. Of course, you can try to do it, but it's going to give you an error saying that the column number is different, and you can't be able to proceed to that. So yeah, now it comes, how do I define properly which one is which, and how do I properly identify and differentiate heat map 1, 2, and 3? So the easiest first thing is to define different colors. So here we're doing 2 color function. So we're using another library called Circleize. I think it's just interpolation of data. Interpolation of colors based on the data. So we're gonna do 2 different set of them. The first color function for the rnorm function. So we're gonna do -3 to 3 using green, white, and red. Okay, and the second function is for the runIf, which is gonna use 0 to 3. So the scaling is 0 to 3, where 0 is gonna be white and 3 is gonna be orange. And the color ram2 over here will try to interpolate the data between like the 1, the 2, 1.5, and so on and so forth between these 2 colors. So it's a gradient. So for the colors of the letters, because it's a categorical data, slightly different. So we're doing like a name list or name matrix, where column A, the character A or the value A will be pink color, the value B will be purple, and the value C will be blue. And you can add however much that you want, so that you can have every color determined directly. If it's not, it might give an error, it might not, but better practice, just name all the colors properly one by one. Okay, so now we're gonna again construct them one by one, but instead of what we did just now, which is just construct a heat map directly without thinking, here we're putting a little bit more parameters or arguments into the creation of the heat map. So you can see that HT1, instead of just the matrix, we also do a name, and we're doing a colors, we're doing a row titles and a column title. So you can actually better just visualize HT1 and how they look. So we can see that the colors are now different. Both heatmap 1 here are being labeled, rnorm are being labeled, and the legend has a different color. So we're doing the same thing with HT2 and HT3. Yep, I have not run that. And then what we do again is we're going to combine them horizontally using a plus sign into a new object called HTList. And then we're going to print the HTList out. So, but when we're printing them out, we are adding actually more parameters in between. So actually just do a comparison between the 2. So if I just simply print the HTList out, they're not going to contain as many information. So I just do 2. So 1 is before we add in the argument before the draw, and 1 is after. So this is the original argument. If you just simply draw the HTList, you can see that yes, I have my title, I have my colors, and I have my things nicely laid out, but it's still not as complete. So what we want to do is this actually. So what we want to do is to do a row title. So 3 heat map row title. You can see the red color thing over here, which is actually defined by a gpar. I'm not too sure what that means, but it's a graphical parameters and something like that. Yeah, that might be the way. Okay, so we're also adding a column title, 3 heat map, column title, and we're gonna increase the font size to 16. Again, I encourage you to change around the color and change around the font size and title to see how you can make things a lot easier for everyone to see. Maybe just do a bold, do an underline, and see if we can get it look the way that you want it to be. So again, I might not actually even use C1 to C10 over here on the 2 different heat map, just to make things a bit clearer. And white and orange might not look that good. But yeah, it depends on what you want. Go ahead and try to change around the color to see what you can do. So the one other thing we can do is actually control or manipulate the size individually for each of the heat map just by here. Yeah. So just by manipulating the width argument of each of the heat map. So just change to 4 cm and 5 mm, and you can make it bigger, smaller, and so on. So maybe Heatmap 1 is incredibly important, Heatmap 2 not that much, and the latter also not that much. So you can try to arrange them to your heart content and how, of course, do you want to tell your story inside your published journal and so on. So yeah, we can again do what's it called, the width of 461 when we combine them, or we can do a 882 when we combine them, so that it will look small, big, big, or you can do big, 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 or something like that. So it's just a way of you to adjust the parameters so that it's just a way for the graph to look differently, practically. Okay, so if you think things are getting too close together, what we can do, again, just be aware that some of the parameters, like the width parameters, is added when you are doing the heat map. Okay, this is the width is added in the heat map function, but the gap over here is added when you draw out the list of the heat map. Okay, you can see the difference. If it individually, the things that you control individually on each heat map, they're controlled in the heat map function. But if things that you control when you combine them together, for example, in this case, the gap between the heat map, they're controlled in the draw function. So just see the distinction here between the two parameters and so on. So there are a little bit more, so actually there's a lot more, but there's one more thing you can do is to change the location of your dendrogram and change the location of the row subtitle site, and we change to the left and right. So you can see before there's a dendrogram right here, there's also then a dendrogram right here. So the difference between here is that you can now see that the dendrogram is now in the middle because we have put in main heat map equals to R norm. Okay, so there's still the norm. So R norm equals to the HT1. So even if we put HT1 in the middle here, because we want them to be in the middle of our plots, we can actually do it here, but they will still draw the dendrogram only on the major heat map and hide the others. Okay, so the next one is, of course, just shift the thing to the side and shift subtitle to the side, to the right and left, so that it looks the way that it is. Okay, so the next one is adding annotation. So for those that miss out what is annotation, there's a video about that last week, if I'm not wrong, or a few days before. You can go ahead and look at them and what they are. So essentially, in a short summary, annotation is just external elements that you add onto a single heat map to indicate extra information about them. So there can be a color, there can be a plot, a dot plot, a summary, a density plot, a histogram, and so on and so forth. So here we're just doing like a simple color. So yeah, what we can do here is that you can see in the middle run if heat map here, we have an extra annotation here called F001. As you can see, they're added here. First of all, annotation object is added with a heat map annotation function. It can also be a column annotation or row annotation. Okay, so if it's 1 to 10, means that it's not a random number, but it's just a sequence of number from 1 to 10. And we are putting the annotation name, which in this case is F001, on the left side. You can see that F001 is on the left right here. And we're adding this HA1 onto HT1 on the top. Okay, so HT2 and 3 are exactly the same, but when we combine them, let's just run the first 5 lines over here. So can you see that? Whoa, sorry, wrong thing. So yeah, when we draw them, can you see that the HT1 now has an extra annotation on the top, which is what we have indicated over here on the top, and the rest remain unchanged. So of course, you can also add the annotation onto HT2, provided that the number of columns are the same between the two. So yeah, depends on, how do you want to pipe it to. So, but you have to understand is that annotation needs to be added to Heatmap before you join them together. Okay, especially when they are like added, or they are not added horizontal, they're not added vertical, they're not vertically stacked. So you are vertically stacking things, which we'll discuss later, then maybe you can do it the other way. But for example, in this case, you just want to add it on one of the heat map. After you want to join them horizontally, this is the correct way to do it. Okay, so the next one will be basically just showing off more annotation. So here we're creating 2 annotations. The first one is a point. can you see that bar 1 is unknown points, 1 to 10. So instead of plotting colors, you can see bar 1 is now a scatter plot from 1 to 10, and we're putting our annotation name on the left. So the second one again is a bar plot, which is again from 1 to 10, and the bar 2 we are changing the in bar 2 they're just automatically just put it on the right so that it looks nicer. So just to add them individually on top, relatively straightforward. HT1 added with the top annotation for HA1. So even though you have single annotation object, one single annotation object can contain multiple annotation. In this case, you have a color and you have a scatter plot, so on and so forth. So HA2, similar concept. HT3, HT1, 2, and 3. So 1, 2, HT3 have no annotation, and we're gonna combine them horizontally again, and we're gonna draw them with a gap of 6 and 2. So you can see that between the HT1 and HT2, slightly bigger, and HT2 and 3 slightly smaller, so you can adjust based on that. I believe they're doing a text repel, which is why they automatically make sure that the text doesn't run into each other and so forth. So there are some of them are adjusted automatically, which is quite clever in this case. So yeah, so now this is just kind of the same concept, just that we added annotation on the row instead of the column. So we are adding a bar plot. As you can see, that bar equals to bar plot, and we are doing a annotation here. Yeah. So combining things from right and left horizontally, basically it can be one heat map added to another, or one heat map added to the annotation, or But I don't think this is a good idea. For me, I would still go for the row annotation equals to this and go forward with that. Kind of preference issue on how do you think it's easier for you to understand. So next one, what is this? Okay, so this is again the same thing. Row annotation equals to so this is a bit more complicated. So we have first of all the annotation, which is, can you see this faint green line on the all the way on the right? Yeah. So the faint green line represent F001, 1 to 12. The second heat map over here, can you see that the plus sign is in the back? So the first heat map is annotation, then we add a heat map in the middle, right here, the green and the red one. Okay, so we have a row k-means to 2, which is we're splitting this heat map into 2 clusters based on k-mean clustering. After we've done that, we are adding another row annotation of a bar plot, which is from 1 to 12 with 4 cm, you can see here. And then we're adding our matrix 2 with a run if all the way on the right again. So yeah, so you can see that you have annotation, which is colors, heat map 1, bar plot, heat map again, and you got all the legends on the right. So yeah, that would be, so basically we have the last one, which is this one. So yeah, again, this is very similar. You can see that up there we have the first heat map here, and we are splitting our row by 2. So you can see row 1 clustering and row 2 clustering. So can you see the horizontal split? Just focus on the horizontal split for now. And then we are adding HT1, we are adding HA onto HT1 vertically using the %V%. So we can see that the second the HA over here is a heat map annotation, which is a bar plot. As you can see, there's a bar plot right in the middle here. And then we're adding HT3, which again has a row equals to 2, meaning it's also split in 1 and 2, top and bottom. And then we're adding finally HT3, which is the lattice, which is actually right here. So you can see that, HT3, yeah. So in HT3, because the length of the column is slightly different, what we have to do is actually trim down our 12 elements matrix right there just now at 12. We're going to cut it to 8 so that it actually fits into the same number of columns as in HT1 and HT2. Okay, so when we've done that, we're going to link HT1 and we combine with HA, we combine HT2 and HT3. So that is where we got our HT list.
And once we have the HT list, we're gonna draw it out using a draw function. And we're gonna do again a column km equals to 3, which is we're doing a column split based on a k-mean clustering of 3 clusters. So you can see again, all the columns are split into 3 clusters. So we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 15 different clusters, very well represented in your heat map. So yeah, this is how you can combine heat map. Just for a great summary, combine things horizontally, use plus. Combine heat map vertically, use %b%. You can combine annotation within the heat map function, or you can combine it after. I would suggest you combine to the heat map function first, so that it's less confusing. And while you're combining heat map, annotation, and so on, make sure when you combine vertically, they have the same column number. You're combining them horizontally, they have the same row number. So that's all about combining heat map. I'm gonna scroll up to some nice pictures, and I hope you enjoy the video. Maybe we'll see you in the next one about oncoprints and some other additional function I find in a heat map. So a complex heat map package. Bye.